So I hope that you have answered all the 10 questions within 10 minutes. Okay. So from today onwards, we'll be doing mock test series for AFCAT examination also. A lot of people has actually applied for AFCAT examination. The exam is going to be happen on September 19th and 20th. So this mock test series will be useful for electronics, all the electronics people. So the subject is given like electrical and electronics. So if you belong to EC, EI or EEE branches, you can watch this video and try answering the questions. So these questions which I have selected is majorly from the previous year question papers of AFCAT. Not very much questions are available over the internet, because maybe of the security issues they have not given all the question papers. Some very few question papers are actually available, and the other questions which I have taken from some standard websites and all. So these questions are actually of the level of AFCAT. The same patterns of questions you'll be finding. And I before giving the solutions, I want to give you the informations about the examination of EKT. So there will be 50 questions, and each question will be given 3 marks. The total timing allotted is 45 minutes. So you have to answer 50 questions in 45 minutes. So the time you'll be getting is less than 1 minute actually for answering one question. But I have given, that is 0.9 minutes only you'll be getting, but I have given almost 1 minute. So you have to answer 10 questions in 10 minutes maximum. Okay, I would prefer try answering the question within 8 minutes, because timing is also very important, right? Okay, so 3 marks for correct answer and -1 mark is for wrong answer. There is -1 mark, or 1 mark is deducted for a wrong answer, and there is no marks for unattempted questions. Okay, so that is the major details you should know about the EKT examination. Now we are moving on to the solutions. So the first question, you can see the questions on board while I'm giving the solutions also. Okay. First question is, given a carrier frequency of 100 kilohertz and a modulating frequency of 5 kilohertz, the bandwidth of the AM transmission is dash. A 5 kilohertz, B 200 kilohertz, C 10 kilohertz, D 20 kilohertz. Now how to answer this question? You have been given the carrier frequency and also the modulating frequency for a AM transmission. So you have to find the bandwidth of AM system. I have done a video on AM, FM and PM. So bandwidth of AM is equal to twice the FM, or the modulating frequency. It has nothing to do with the carrier frequency generally. So it will be 2 into 5 kilohertz, which will be 10 kilohertz only. Okay, 10 kilohertz is the bandwidth. Okay, so the correct answer is option C is the correct answer for your first question. So while solving this question, you should know this formula, that for a amplitude modulating system, bandwidth is twice the modulating frequency. So 2 into 5 kilohertz here and 10 kilohertz. So that carrier frequency is actually given to confuse you. Okay, so it has nothing to do with your bandwidth. Okay, correct answer is option C. Out of the following, which one is the least commonly emitted radioactive substance? A, electron, B, electromagnetic radiation, C, alpha particles, D, neutrons. Correct answer is option D, neutrons. Okay, so neutrons are the least commonly emitted radioactive substances. Okay, so you can also find these type of questions which is from the physics subject. So you have to be facing these basic questions also along with your subject knowledge. Okay, here the correct answer is option D, neutrons. Quantization noise occurs in dash. A, PCM, B, time division multiplexer, C, FDM, D, PPM. So out of the given options, only one modulation, all the these are not modulation techniques actually. Multiplexing techniques are also given, but out of these 4 options, only one is digital modulation type. In only digital modulation, you require quantization, sampling and quantization, and only while performing quantization noise is happening or formed, right? So here PCM is pulse code modulation, which is actually a digital modulation technique. Okay, PCM is pulse code modulation. Okay, so in which you have to sample and quantize the signal. So in that case, quantization noise is obvious case. Then for B, time division multiplexer is not actually a digital modulation technique. It is just a multiplexing, combining and decombining. You know the function of a mux, right? Then FDM is frequency division multiplexing. Then D is PPM, pulse position modulation. It is again an analog modulation techniques, not a digital one. So in digital modulation techniques only you can find quantization noise, which is only option A here, PCM. Okay, correct answer is option A, which is PCM. Which of the following antennas is best excited from a waveguide? Okay, A biconical, B horn, C helical, and D disc horn. So if you have done your laboratories of microwave, so you will be seeing this horn antenna. So generally waveguides or the antennas which are best excited by the waveguides are horn antennas. Okay, so this will be roughly a structure of a horn antenna. So generally the horn antennas get best excited from the waveguides. I've done a video on the types of antennas. You can find the various antennas, radiation patterns and everything over there. Please to watch that video. Okay, so the correct answer here is option B, horn antenna. So the waveguides are generally used to excite the horn antennas, and it is best, these antennas get best excited with the waveguides. Okay, correct answer is option B. Question is question number 5. A Yagi antenna produces dash. A 8 pattern, B broadside pattern, C end fire array, D helical pattern. So a Yagi Uda antenna is looking like this. It is an array type of antenna. Again, we have discussed about this in the type of antennas. Okay, so this is the structure of a Yagi Uda antenna, and this Yagi Uda antenna, this is a feed point. So this is roughly, it will look like this. So this antenna produces a end fire array pattern. Okay, so the correct answer is the radiation pattern is an end fire array type. Correct answer here is a option C, end fire array. The decimal equivalent of hex number E5 is dash. So this is a question from digital electronics. You have to find the decimal equivalent of the hexadecimal number E5. Okay, so hexadecimal, we know that it is to the base of 16. So if you write this E5, you can write it as 16 raised to 0 is the position value, 16 raised to 1. Okay, so we can write it like below E5, we can write like this in order to convert to decimal. So E, we cannot multiply with the 16. So we are going to write the corresponding number. E means 14, right? So in order to find the decimal representation, we are going to multiply these two numbers. 14 into 16 raised to 1 plus 5 into 16 raised to 0. Okay, so if you sum it up, you will be getting 229 to the base of 10. So this is how you convert a number from hexadecimal to decimal. So I will explain once again. So the hexadecimal numbers are numbers which are represented to the base of 16. So in order to convert that to decimal, we are going to write the numbers, and below which we'll be writing the first position values. It is 0 and 1. Then we'll write the position to the power of 16 as powers of 16. 16 raised to 0, then 16 raised to 1 here. So if there is another number, that number below that we'll write 16 raised to 2. Then we'll take the product and sum. So 16 raised to 1, here there was E, but we need a decimal number. In decimal there is no E, there is no F, there is no A. So we have to write E means correspondingly the number representation is 14. So 14 into 16 raised to 1 plus 5 into 16 raised to 0. So this sum will be 229, which is the number in decimal. Okay, so the correct answer is option B, 229 to the base of 10. Okay. Question is, dash is used for keeping oscillator frequency away from drift. A. PLL, B. VCO, C. comparator, D. frequency synthesizer. So in order to keep away the drift from the oscillator, we use a phase lock loop. Okay, so a PLL is used for controlling the drift or the change in frequencies. Okay, so the correct answer is A, phase lock loop or PLL. So the other options are VCO, voltage control oscillator. No, it is actually voltage controlled oscillator itself. It is not actually used for, it is not used as a control element in the another oscillator. Then C, comparator, no. D, frequency synthesizer, also no. So the correct answer is PLL. The next question is, the energy stored will be least in which of the following components? A, coil or inductor coil. B, capacitor. C, resistor. D, same energy will be stored in all. Okay, so out of these given elements or components, we know that from the by reading the option itself, it is very clear. The correct answer will be C, because we know that resistor is not an element which is serving the purpose of storing energy. It is used for blocking the flow of current. It will actually dissipate the energy in the form of heat. Okay, so it will not store any energy. Coil will also store some amount of energy. Capacitor is actually meant to be storing energy or charge. Okay, so the correct answer is option C, resistor. It is not, or it will be storing the least amount of energy. Okay. Next question is question number 9. The target cross section is changing. The best system for accurate tracking is dash. Okay, so the question is regarding to radars. There are various parameters of the radar. There is transmitted power, there is radar cross section, minimum detectable signal. So there are a lot of videos in radar playlist. Please do watch it in order to have the basics of radar. So there are various types of radar, out of which radar you can depend on if the cross section of the target to be detected is changing. Okay, so this is represented using the letter sigma. Okay, now if it is changing, which radar you can depend on? A, monopulse. B, conical scanning. C, sequential locking. D, lobe switching. Okay, here the correct answer is monopulse radar. Okay, so if the radar cross section, so there is a radar and there is a object which we need to detect. So there is some cross sectional area of this target which the radar's signal is actually hitting and coming back. So this cross section or sigma actually matters to the radar. So the radar will be sending some pulse and it will be receiving the echo. This is the basic working of a radar, right? So this cross section of the target, if it is not fixed, if it is varying, we can use a monopulse. Okay, monopulse type of radar we can use, and the correct answer is option A. In a two-cavity klystron, the input cavity resonator is also known as dash. A, velocity modulator. B, catcher cavity. C, buncher cavity. D, accelerator. Again, we have done a video on two-cavity klystrons in which we have discussed about the basic working, the electron velocity modulation, about the cavities and all the parameters we have discussed. So, for a two-cavity klystron, there are two cavities anyway. The first cavity is called the buncher cavity. Okay, so the answer here is buncher cavity. And the second cavity is called the catcher cavity. So the electrons passes through these two cavities and get velocity modulated and will be higher velocity electrons. Electrons passes through these two cavities, the buncher and the catcher cavity, and it will get accelerated, and finally after passing the catcher cavity, this high velocity or the kinetic energy is absorbed by some microwave which we want to actually amplify, and the electrons will get slowed down. Okay, so that is the brief working of a klystron, and here the process happening is called velocity modulation. And the question is not any of this. The question is regarding the cavities. So there are two cavities, buncher cavity and catcher cavity. So in the buncher cavity, we'll be passing some wave which we want to amplify. And from the catcher cavity, we'll be taking out the wave which is actually amplified version. Okay, so the correct answer here is option C, buncher cavity. It is not any of the other options. The correct answer is C, buncher cavity is the correct answer for 10th question. So these are the 10 questions which I have included in this video. So this video is a basic one with little simple questions. In the subsequent parts, we'll be including more difficult type of questions. Okay, so if any of your friends is preparing for AFCAT examination, please do uh, share this video with all those friends. And if you found the video useful, please do give it a thumbs up. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.